Hi students, my name is K. Naras, working as a assistant professor in the Department of Civil Engineering. So as a part of the video lecture, I'm explain about population forecasting. Population forecasting, it is the part of the environmental engineering. So first of all, enter into the definition. So population forecasting is a method by which we calculate the future population of any city or region at the interval of a n number of decades is known as a population forecasting. So this population forecasting which is used for the design of water supply system and sanitary system, which is based upon the project population of a particular city and estimated for the design period. So if the population estimation is so underestimated underestimated, that will make a system is inadequate for the purposes, and similarly so the population is overestimated value, that will make a cost of the structure. So the change in the population of the city so over the years occurs, and the system should be designed taking into account of the population at the end of the so design period. So this population forecasting, there are some factors are affecting. So they are so increase due to birth rates, decrease due to death rate, and increase due to migrations, and increase due to annexation. So number of people's birth in a year, and number of people's death in a year, and number of people's so migrated into a another countries or another regions. So these are the factors affecting on the population forecasting. So in this population forecasting, the present and past population record for the city can be obtained from the past census population records. So after this record collections, this population figures, the population at the end of the design period is predicted by using various methods. They are suitable for the city considering the growth pattern followed by the city. So there are the some methods of the population forecastings are there. So they are, first one is arithmetic increase method, and the second one is geometric increase method, and third one is incremental increase method, and fourth one is decrease rate of increase method, and fifth one is graphical projection method, and sixth one is comparative graphical method, and seventh one is master plan method, and last one is logistical method. So now going to the in detail. So first one is arithmetical increase method. So arithmetic, in this method, this is the simple method which is used for the calculation of the population of a large cities with considerable development, and which is not used for the small cities because it gives the lower value. It gives the lower value than the actual value. So in this method, we consider that the rate of change of population, that is dB by dt is equal to C. So where C is equal to constant. So the average in this method, the average increase in population per decade is calculated from the past census report. So the increase is added to the present population to find out the population from the next decade. So it is assumed that the population is increasing at a constant rate, that is dB by dt is equal to C. So in this method, the rate of change of population with respect to the time is equal to constant. So the population after n decades will be, so Pn is equal to P naught plus n into I. So where Pn is equal to the population after n decades, where P naught is equal to P naught is equal to last known population plus n is equal to number of decades between present population to future population, and I is equal to the rate of population growth. So we take one example that is given below. So there are the number of years are there, and that specific year there are the populations are given in the tabular format. So that is 1930 25,000 population was there, at 1940 28,000, and 1950 34,000, 1960 42,000, and 1970 47,000. So here one question is there. So with the help of the above given data, so to find the population of the year 2020 by using arithmetic method. So the arithmetic method formula is, so Pn is equal to P plus n into I. So first of all, first step is to find the increase in population each decade. So in this process, so first step it is to identify the population P1 and P2, P3, P4, P5. So the next column, we take the next column is, so increase in population. So increase in population, so I1 is equal to, so P2 minus P1. So where P2 is equal to 28,000 minus 25,000, so that equal to 3,000, where I2 is equal to, so P3 minus P2. So P3 minus P2, 34,000 minus 28,000, that is 6,000, and I3 is equal to, P4 minus P3, 42,000 minus 34,000, 8,000, and I4 is equal to P5 minus P4, 47 minus 42,000 and 5,000. So next step is to find the average rate of increase in population. So I is equal to I1 plus I2 plus I3 plus I4 divided by number of increase in population. So we get the I value, and step 3, then go to the next step, that is find the number of decades n between the last known year to the required year. So here the number of decades from the 1970 to 2020, there are the 5 decades are there. 1970, from 1970 to 98, 1 decade, and 1980 to 1990, 2 decades, 1990 to 2000, 3 decades, 2000 to 2010, 4 decades, 2010 to 2020, 5 decades. So here, to apply the formula in step 4, to apply the formula, Pn is equal to P plus n into I. So Pn is equal to 2020 is equal to present population are given in 1970 is equal to 47,000. So 47,000 plus n into number of decades 5 into the average increase in population 5,500. Here the total population of the total population in 2020 is equal to 74,500. Therefore population at 2020 will be 74,500. Here I will enter into the next method, that is geometrical increase method. So geometrical increase method, the increase rate of the population is not constant. In this method, it does not rate of change of population with respect to the time. So the percentage increase in population is considered. This method is suitable for the small cities or new developing towns for a few decades years, because it gives the higher values by the percentage increases. Percentage increases. Here geometrical increase method, they given the given formula. So Pn is equal to P into 1 plus R by 100 into power n, where Pn is equal to future population, P is equal to present population, R is equal to growth rate, increase in population by initial population into 100, where n is equal to number of decades. Coming to the, so there are given problem is there. So geometrical method, same process are followed, and coming to the third method, that is incremental increase method. So this method is the combination of the increase and incremental, arithmetic increase and incremental method increase method. So in this method, it is the combination of the arithmetical mean method and geometrical mean method. As here the problem, the formula is given. So Pn is equal to P plus n into I plus n into n of n plus 1 by 2 into R. So where P is equal to present population, where Pn is equal to population after n decades, where n is equal to number of decades between the P naught and Pn. So P naught is equal to Pn. I is equal to average of increase in population, and R is equal to incremental increase of population. So this method is adapted to the increase in incremental is considered for the calculating future population. So this incremental increase determined for the each decade from the past population, and the average value that is added to the present population along with the average rate of increase. Here problem is given. So the process will be same, and to find out the incremental increase in population, and the next column is incremental increase in population. So here, so 1930 2000 25,000 are given, and 1940 28,000 is given, and 1950 34,000 is given, 1960 42,000 is given, and 1970 40,000 is given. First of all, you find the, so increase in population. So they are using I1 is equal to B2 minus P1, and I2 is equal to B3 minus P2, and I4 is equal to P3 minus P4, P4 minus P3, and I4 is equal to P5 minus P4. So here to find the I values 3000, 6000, 8000 and 5000, and here one step is added to, that is incremental increase. So incremental increase R1 is equal to I2 minus I1. Here 6000 minus 3000 is equal to 3000, and I2 I3 minus I2, here 8000 minus 6000 is equal to 2000, and R3 is equal to I4 minus I3, here 5000 minus 8000 is equal to minus 3000. So we find the I and R value, average increase in population and incremental increase values respectively. I is equal to 3000 plus 6000 plus 8000 plus 5000 divided by 4. So that equal to 5500, and R is equal to 3000 plus 2000 minus 3000 divided by 3. So R is equal to 2000 by 3. So we find the step 4, find the number of decades between the last known to year to the required year. So that is equal to, number of decades is equal to 5 decades from the 1970 to 2020. So apply the formula. Pn is equal to P plus n into I plus n of n plus 1 by 2 into R. So here substitute the R value and substitute the I value and substitute the N value. So we get final answer. Therefore, the population in 2020 will be 84,500. So now coming to the next method, that is decrease rate of growth rate, decrease rate of growth method. So here this method is adapted for a town which is reaching the saturation population where the rate of population growth is decreasing. In this method, the average decrease in growth rate S is considered. S is considered. So here formula is given. So Pn is equal to Pn minus 1 plus R into N minus 1 minus S divided by 100 into P into N minus 1. So Pn is equal to population at required data and Pn minus 1 is equal to population at previous decade or predicted or available, and Rn minus 1 is equal to growth rate at previous decade, and S is equal to average decrease in growth rate. Average decrease in growth rate. Here the next method is graphical projection method. So the graphical projection method, the population versus time graph is plotted and it is extended according to find the future population is to be done by the an experienced person, and it is almost always prone to the error. You clearly observe that there are the two coordinates are there, and x-axis and y-axis. X-axis represents the time and y-axis represents the population. If the time increases from the decade to decade, the population also increases. The population increases and the time increases, that will be plotted on the graph. So this method is called as a graphical projection method. Now coming to the next method, so comparative graphical method. So comparative graphical method, in this method the population data of a project is plotted along with the past population data of a number of towns which have the grown under the similar conditions. The curve of the city under considerations is extended carefully after studying the pattern of the other cities. Other cities. Now coming to the next method, that is master plan method. This method is used for a completely planned city that has a not meant to be developed in a haphazard manner. So in this city, it can be divided into number of zones. Number of zones. So number of zones. The zones includes the commercial areas and industrial area and institutional area and gardening and parks and industrial areas. So these are the example for zoning methods. And last one is logistic curve method. So here we clearly observe that the one graph is there. So with respect to the time, so here graph is plotted with x-axis and y-axis. X-axis represents the time and y-axis represents the population. Here clearly observe that. So here J to K, so here the population to increase in a very little, and from the K to M population increase in very high, and M to N population is reached to the very high. So here J, K and Mn is the, so J, K and Mn is the S shape. It is clearly observed that is a S shape curve. The S shape curve is called as a logistic curve. So the logistic curve method is suitable for the regions where the rate of increase or decrease of population with the time, and also population growth is likely to reach an ultimate. So here clearly observe that saturation limit because special factors, the growth of the city which follows the logistic curve will plot a straight line on the arithmetic paper with time intervals plotted against the population percentage of the saturation. Thank you.